Okay, so again, if we define the reflection coefficient to be the ratio of the intensity of the left moving plane wave in the region x is less than 0, that is the one that corresponds to the the left moving plane wave, okay, with characterized by coefficient b, to the intensity of the right moving plane wave, the one that's characterized by the coefficient a, okay. And if we plug in the relationship for the intensities for both those two plane waves, then we find that we just get b squared times h bar k1 over m divided by a squared times h bar k over m. Obviously these cancel, and this is equal to b squared over a squared. And then if we look and see what we found, if we divide this, so what we find is that b squared divided by a squared is just k1 minus, is just this thing squared here, okay. And so this is equal to k1 minus k2 divided by k1 plus k2, this quantity squared, okay. And similarly we can define the transmission coefficient, okay. Okay, so we can define a transmission coefficient T, which is equal to the ratio of the intensity of the plane wave which is transmitted, characterized by the coefficient C, to the incident intensity. And if we plug in the relationships again for the intensities, we get C squared h bar now k2 over m, k2 because this is in the x greater than 0 region, and a squared h bar k1 divided by m. And so obviously we see that this is equal to k2 over k1 times c squared divided by a squared. And again, if we do the math, this is equal to 4 times k1 k2 divided by k1 plus k2. And again, you can show that the you can plug in for the energies. You can substitute for K1 and K2. You can substitute in the appropriate expressions that include the energies and potential energies, the total energy and the potential energy of the step. Okay, and I'll leave it as an exercise, but you can show that R plus T is equal to 1. That is the probability of the particle reflecting plus the probability of the particle transmitting has to be equal to 1. It has to do one or the other. Okay, it has to reflect off the barrier, or it has to be transmitted through the barrier, but it can't do anything else. Now, one of the things that's important to realize is that there's this transmission coefficient T is not equal to 0. So in general it's not equal to 0, neither is the reflection coefficient. And so the general case is that we have both reflection and transmission for a particle. And now what we're going to do is consider the case when the total energy of the particle is either greater than or less than the step height.